Good evening, everyone. Welcome for today's session. So let me share the screen now. I hope everyone able to hear my voice, right? Yeah, I hope. Okay, fine. Okay, fine. So welcome to our once again. I welcome everyone for today's session. So today is officially we are the second day of session, right? So we are in day 2 in trade analytics program. Okay, fine. So in trade analytics, very first day, what about our agenda of this? Again, I will explain you today. So our agenda is very first day, we discuss about the day 1. We discussed about application of ML on trade analytics domain or trade domain. That means stock market or equity. We discussed about it. Day 2. So day 2 now today. So we are going to discuss about CRISP MLQ methodology in machine learning. Day 3. So we are going to perform data pre-processing technique. Day 4. So day 4, we used to take one use cases and we are performing k-means clustering. We are going to perform use cases of k-means clustering. Day 5th, we will discuss about KNN neighbors, another use cases. KNN neighbor use cases. So first 3 days, you don't get any algorithm. You're not going to use any algorithm. Some basic things we are going to discuss. From on day 4, we used to cover any one algorithm. It can be supervised or it can be unsupervised machine. So the day 4, we use k-means clustering. Day 5, we using KNN technique. Day 6, we will use decision tree on any one algorithm. Day 7, we will discuss about linear regression technique. It's a supervised machine learning. So K means unsupervised machine learning, KNN supervised machine learning, decision tree is supervised machine learning. So linear algorithm, linear regressions. So where we are going to deal with linear regression. And day 8. So day 8, we are going to discuss about MLP concepts, multi-layer perception, neural network. So we are going to work with the neural network. And day 9, so we will discuss about some text mining. And day 10, yes, we will discuss about some decision tree or MLP concepts, some other concept, the extension of the algorithm, or we will use the new algorithms. So this is about our plan. Got it? So in trade analytics, how we are going to perform, how we predict the future or the future equity, or which share market price will be keep increasing? What is the sentiment analysis towards the share market? So all we are going to discuss in our 16 hours program. The sessions pertaining to 16 hours. Okay. So in the 16 hours, every day we have 1.5 hours or 2 hours. On final day, we have only 1 hour. So that's what our plan. So those who are not following previous videos, yes, everything updated in YouTube. So we have keep conducting on different domain analytics, more than 56 plus domain analytics we are performing. So each domain, so we are using machine learning algorithm on specific domains. Instead of taking general data science, yes, we are performing on different field or different domains. We used to perform on it. So without wasting time, let's quickly start. So today agenda, the stages of analytics. Yesterday we talked overview, but today we'll go into the deep of stages of analytics. And we will talk about CRISP QL methodology, the inferential statistics, what is supervised, what is unsupervised machine learning, data split, and error function. Right. So all these things we are going to look today in deep manner. So these are the things are essential to learn analytics, trade analytics. So you may have an idea about trade, but you may not idea about what is in data science perspective. So we will talk about that. Let's go now. Yeah, in trade analytics, we are going to talk about the first thing, stages of analytics. The data analytics is a valuable tool for business, which aiming to increase the revenue or improve the products or retain the customers. Okay, so ultimate aim is, what is data analytics? That is the aim. What is data analytics? So analytics means collect the data, used to collect the data, right? And it used to analyze the data by using different tools or different algorithms or different statistics. But ultimately, we are going to get some meaningful insight. Meaningful hidden insight. Got it? So meaningful hidden insight or meaningful hidden pattern. We used to call as pattern. Right? So collect the data, the big data, past data or historical data, any name you have various names to call. So we collect the data from different sources, and we do our analysis by using some statistical method or mathematical foundation. So ultimately, we used to get hidden insight or pattern. So this is called prescribed total stages of analytics. So we have majorly classified into 4 stages. We majorly classified into 4 stages. Prescriptive analytics, predictive analytics, diagnostic analytics, and descriptive analytics. So each stage having some characteristics or some example in corporate or in business. So we are going to look each and every concept in detailed manner. Here, the first one is descriptive, second diagnostic, third predictive, and fourth prescriptive. We need to go from down to up. So whenever you receive the data, when you receive the data, the first thing what you need to do, you need to understand the business problem. See, I want to relate this analytics with our basic day-to-day life. Okay. So when you are going to the doctor, let's assume that you are not feeling well for last 2 days. Let's assume some stomach problem or stomach pain, something, some issue, some ache, some itch in your body. So what do? You go to the doctor. So once you met the doctor, whether doctor is writing description immediately or prescription immediately without asking anything, no, right? So he is asking what is happening. He tried to understand the situation, or he tried to understand what has happened to you or what is happening to you in your body. In first-hand information, he tried to understand. He tried to understand what is happening in body, in your body. Right? What is happening in your body, or what is happening in your business. Same way COVID situation. All the government or ministry, just they want to analyze or they want to know what is happening in the country. The COVID spread, and they try to understand how much spread is happening, or from which state or which country it is come from, it is spread over from. So what is the range of the density, that effectiveness, how fast the spread is. So they try to understand the first-hand information. Try to understand the first-hand information. So that will talk about descriptive analytics. When come to business level, descriptive analysis, it is a process of using current and historical data to identify the trends and relationship. So the descriptive analysis is the process of using current trend. This is the process of using current trend. We can say another name, business, current trends and relationship of the data. So it used to describe the trend and relationship, but not going to deep into that. So while you are using this, while you are explaining descriptive analytics, most of the time we use to Microsoft Excel or data visualization tool, right? Microsoft Excel, MS Excel we used to do. We use it, we show the trend of the pattern or relationship, if there is any relationship. Okay, so regarding to the trend, anything regarding to the trend, we can use descriptive analytics. And in business level, I can give you some example towards the business. For example, traffic and engagement report. Some reports, traffic. Or financial statement analysis. The best thing is financial statement analysis. Financial statement analysis. So it will show you the financial statement analysis of statement. It shows the periodic report in detail financial information about business, right? So we have a different in the company. If you look at the company, there are different kind of financial statements. For example, balance sheet, income statement, cash flow statement. So these are the report which we are using to identify the pattern or ratio analysis. So this all comes under descriptive analytics. We have a demand trends. Demand trends. What is the demand trends? That used to identify the trend in the customer preference or behavior. For example, let's say we can say the Netflix, right? So this will analyze the data to determine whether people are more watching on TV or any series or any movies at given time, at given point of time, what is most they would like to. It is not only for using the popular, but what people are enjoying, which actor film they are like most, which journal they like most. There are so many things they work on. I hope I gave some sufficient example, right, regarding the descriptive analytics. Yes. Okay, next we can come the second step. So this needs to be done by step. Okay, we cannot jump from 1 to 4. Should be order. The data analytics should be order. So first thing what we discussed about overall what we understood. Descriptive analytics which answer the question of what happened. Okay, answer this question. Next, we have a diagnostic analytics, second stage. So which will give you an answer for why did this happen? What happened and why happened? Why did this happen? Yeah. So as all of us know, each data analytics, each data types or each data analytics, it helps to achieve some goals. So diagnostic analytics is nothing but it's a process of using data to determine the causes of trend. See, this will use to find the trend and relationship, but this will help to find the causes of the trend and relationship, correlation. Used to say correlation between variables. So some of the technique we used here is the correlation or hypothesis testing. All of us know hypothesis testing. See, the hypothesis testing is a statistical process for proving or disproving an assumption. Your assumption is something. So we use some process to check whether it is a proved or not. Our assumption is proved or not. And we have correlation. The correlation means exploring relationship between the variables. So it's used to important to aware of distinction between correlation and causation. But we have different diagnostic regression analysis we have. So what is the example? So yeah, the first step, descriptive analytics, will help to talk about what happened. So diagnostic analytics will talk about why something happened. Predictive analytics will talk about. Now we will complete second, then we will go for third. So we can give you some example. For example, identifying market demand. You are examining or identifying market demand. And explaining customer behavior. the customer behavior can be identified by the diagnostic, because maybe why the sales is decreasing, because the customer may not satisfied with the product or with the services of the company. And regarding market trend, why sudden decrease in sales? Why sudden, right? Why sudden increase or why sudden decline in the sales? Sometimes we can able to identify technology issue also by using diagnostic analytics. We can able to perform some technology issues, because some of the algorithm are constantly working in the background of your machine. Okay, so the diagnostic, it's also necessary to check. So ultimately, this diagnostic analytics will help to identify the reason or causes of the problem. So first stages of analytics, we'll talk about descriptive. Second stage, diagnostic. Third stage, predictive. So predictive analysis, what is predictive analysis? The predictive analysis is used to predict the, or it's used to predict the future trend of events. Used to predict the future trend of the business, future trend of the business or event. The first thing, we are trying to find the trend. Second thing, we try to find the causes of the trend. Then we're trying to find the future of the trend. How it could be. For that, it used some historical data to forecast potential scenarios. So one predictive analytics algorithm is regression algorithm. Regression, simple linear regression as well as multiple linear regression. So why do we use regression technique? So the regression will help us to get insight into the structure and relationship between the variables. So one of the best example we can say it's a forecasting. You can do forecasting. Okay, what is the example for predictive analytics in action? The forecasting future case flow. For example, every business there is need to keep periodic financial records, right? So based on the historical financial records, by using machine learning algorithm or the predictive algorithm, we can able to forecasting the data or forecasting the sales or forecasting the profits. It's widely used for entertainment and hospitality to determine the staff needs. Third thing, we can talk about behavioral targeting. It is related from business. I'm using too much business term, but I will explain you about some basic life example for that. The real life example I will let you know. I can just tell you some real life example. For example, as mentioned before, when you go for doctor, when you're going for doctor, right? So doctor, as usual, we discussed about descriptive analytics. He tried to understand the current condition or past conditions. Then he is doing diagnostic method. By using diagnostic method, he tried to understand for the reason of the problem. And third stage, predictive analytics. So once identify the reason, maybe headache or stomach pain. So once you understand the reason, then you can use this for prediction. You can use for prediction technology, predictive technology, predictive method. So the descriptive analytics will talk about what will happen. Diagnostic will talk about why this has happened. Predictive analytics talk about what will happen. And prescriptive analytics will talk about what needs to be done. This is the final stage. Okay, this could be a final stage of any data analytics. Right. So descriptive, diagnostic, predictive, and prescriptive. So now we can look at what is prescriptive data analytics. So this solution stage problem, we try to understand the reason for solution or reason for the problem. Okay, to try to understand the reason for the problem. So there are many examples we can use for this. So it is the process of using data to determine optimal course of action. Optimal course of action. So what needs to be done? That solution should be optimal. Optimal means maximization and minimization. For example, investment decision, venture capital, or sales lead scoring, or fraud detection, development and development and improvement for product management, email automation. So these are some solutions for the problem. So in 4 stages of analytics, we talk about descriptive, predictive, diagnostic, and descriptive stages of analytics. I think this one more time one here. Yeah, let us look at another concept. The next primary things what we are going to look into the crisp MLQ. So let me open new slide. That will be okay. Okay, let me explain here. So what is crisp MLQ? So crisp, let me open here. Sorry, my bad. Okay, so what is crisp MLQ first of all? Let me explain you about the expansion, then we will talk about crisp MLQ. So crisp MLQ is cross industry standard process for machine learning. For machine learning with quality assurance. Okay, cross industry standard process for procedure or process for machine learning with quality assurance. See, if not only data science guys, if you take any companies or any project they take a new project or the new statistical method or some new business they start, they need some guidelines, right? Some procedure to follow that. That procedure it's called as project management methodology. So the method or guidelines is called as project management methodology. Okay. So there are different kind of project management methodology for different industry. Every industry following some different method. Some famous methodologies: waterfall, agile, IT industry, Scrum. Okay, Scrum, agile software development, waterfall. So these are some essential. Kanban board, Scrum Ban, critical chain project management, lean manufacturing. There are multiple project management, each one following their own procedure and yes, their own procedure and methodology. But for come to data science, when come to data science, we are following some standard method, some standard project management methodology that is called CRISP MLQ. That's called CRISP MLQ. So in CRISP MLQ, we have 6 stages. So why do we use CRISP MLQ? Because it will helps to increase the success rate of the project, increase the success rate. So there are 6 stages we have. One is called business and data understanding. We will look at that. Yeah. So we have a business and data understanding, data pre-processing, model building, model evaluation, deployment, and monitoring and maintenance. So we are going to see each and every topic in detail, or else in detail we will look at that, what is happening in the CRISP MLQ. The first stage is business and data understanding. The first stage is business and data understanding. So business and data understanding, what we do, we have divided into 2 types, 2 subcategories: business understanding and data understanding. So now we look at business understanding. So in business understanding, we are going to talk about project charters, and we discussed about optimization, and we discussed about objective and constraint. See, the CRISP MLQ methodology is a life cycle of the data science project. We cannot stop with the single phase. Okay, so we need to follow the step for any project you are taking. Right. So what are the project? What are the projects? What are the project? Whatever project you take, the first thing you look at into the business understanding. So project charter, project charter is nothing but the first document we prepared in any of the projects. Right? Project charter is the document, the first document we prepared for any of the project. Then what should be contained? The project. Then what it may contain? So it is having the project charter recording all business objectives and constraints, and we discuss about, and it's used to record on milestone of the project, right? Duration of the project, employee, how many employees are working on the project, challenge of the project, challenge, the opportunity of, or any changes you made. So any changes you made in the record, so you need to document. So this will help you to avoid miscommunication. So it helps to avoid some miscommunication between the client and sponsor, client as well, between client and the data science team. There are various meetings and various documentations prepared, MOM prepared. There are multiple things options can be. So ultimately, we have to come up with some document that needs to be filled by everyone. Every detail needs to fulfill. Okay, just a minute, yes, just a minute. Okay, fine. So project charter, we have document. These are the important constraint, important things need updated. And other thing we are discussed about in the business understanding, we come across success criteria. Okay, in success criteria, we used to have business success criteria, and ML success criteria, then economic success criteria. So every success criteria, we have come up with some stats or some numbers. So business success criteria, in business success criteria, it is rely on, or it is rely on the objectives. It's related to the objectives. When come to ML success criteria, it is talk about ML success criteria. It's talk about the percentage, some percentage of machine learning. For example, accuracy and efficiency is the two factors. Accuracy and efficiency is the two factors for your machine learning. So any machine learning model you are run, you are expected to be use of these things. You expected to be consider these two things. ML success criteria. And you have economic success criteria. In economic success criteria, it is based on the revenue concept. It's based on the revenue. So how much revenue is getting generated because of applying model? What amount of revenue you are generating? So that can be carried out by using economic success criteria. So business success criteria, it's related to the objective of business. ML success criteria related to your model you are building, which model you are building. And economic success criteria, it is for economic success criteria for revenue related. Okay, it's called revenue related things. How much, because of applying this model, how much amount you are given out. So that we will talk about in success criteria. Okay, and another thing is how to frame objective and constraints. See, why do we use objective and why do we use constraint? Because if you are giving objective alone, anybody can give a solution for this. For example, some person in bank, let's take bank example, some significant amount of customers or keep complaining, or the significant customers, they are not repaying the loan. This complaint from bank manager. So the bank manager comes to you and he need the data scientist help. What is that? He need data scientist help. So every bank must maintain NPA percentage. That means they control NPA. What is NPA? NPA is non-performing asset. Non-performing asset. Non-performing asset. See, when you say defaulter, so defaulter means the person who are not repay the loan for continuously 3 months. The person who are not repaying the loan for continuously 3 months, then the person is called as defaulter. So every bank has maintained, or every bank has planned to or trying to reduce the NPA percentage. So the government has set up some percentage, some determined some percent, for example, 2%. So every bank should not be cross 2%. So what should be your objective in case if the problem statement is, if your problem statement is defaulter. So what could be your objective and constraint? So objective should be minimize the fraudulent or minimize the defaulter. Sorry, my bad. So objective should be minimize the defaulter. Then what could be the constraint? Why the constraint come to the picture over here? See, if you're not giving constraint is a condition. If you're not giving condition, what happens here? We can give n number of solutions. Right? So as a common people, anybody can give a solution and n number of solutions we can give. But okay, in case what should be your solution, guys? What could be our solution? Our solution could be don't give loan. Right? So don't give loan is the primary answer as a common people. Everyone used to say don't give loan or stricten. You collect that very strict document. So that could be your objective. That could be your answer or recommendation. If you're not giving constraint. But think about that. If you are keep rejecting the loan, then how will the bank will get benefited? how the bank is going to get benefited. Correct. So the purpose we are putting constraint towards the problem statement. So when you put a constraint, at the same time, the condition here is maximize the profit also. Maximize the profit means you cannot keep rejecting, keep the loan as it is. So that there is a very interesting factor come to the picture. As a data scientist, we have an algorithm called survival analytics. Okay, we have a called survival analytics. So in survival, by using survival analytics, what you can do? You can able to predict, or you can okay. So you can able to predict how many months the previous same kind of pattern customers are repaid the loans properly. Right? Maybe the same character of customers can be, he can be repay the loan properly until, for example, 24 months. So out of 24 months, he may be paying for 1 year or 1.5 years. He repaid the loan properly. There is chance. So instead of rejecting the loan, we can minimize the loan amount. So we can minimize the loan amount. Accordingly, we can provide the loan, or we can approve the loan accordingly. So that things, yes, we can perform on it. And when come to other techniques, so this is about business understanding. There are multiple various examples we can give towards business understanding. The ultimate aim is to understand whenever you are having business problem. Accordingly, you need to create or you need to frame your objective and constraint. There are good amount of things has to become one way. Okay, fine. So business understanding, we understood now. So now we have the subcategory is called as data understanding. See, what is the necessity of data understanding? What would be necessity of doing data understanding is? What do you do in the data understanding? So the quality of data, right? The quality of data is very fundamental to every data science project. So in order to get a gain or in order to get a meaningful insight, the appropriate data should be taken. Okay, so in data understanding, the first step of data understanding is data assessment. So this should be undertaken before kick-off any project. So how do you evaluate? What are the questions comes to your mind? What data is available? Okay, how much data available? What format data will be? Where does it reside? How can we access the data? Which field are more important? So these are all the things is considered as a data understanding. How does the data map to the current method of completing the task today? What are the important metrics are reported using this type? Right? So we are looking at the quality and quantity of data. So data understanding, we are looking for quality and quantity of data. The main key consideration is collecting ground truth data. For example, if you wish to make prediction using machine learning algorithm, so you need some label data. So for each example, you need the correct value and appropriate category. Correct. So this is may already available to you at this action of yours. And data relevance. So whatever data you have, you should have a proper data within your data set to prediction. Quantity of data. To successful machine learning model, you must be sufficient data. There is no strict rule to calculate how much should be used for dependent on the complexity of your problem. This based on the complexity of so you can also use the predicted output to estimate the number of sample you need. Okay, then we can do it for some data exploration. So once we collect the data, then we can do it for data preparation. In data understanding, so in data understanding, what did we understand that? The data assessment, right? The first step is understand the quality data is fundamental to any data science. So you should understand the data before. What is the data available? How much data, as I mentioned before. This thing you need to be understand that. And when come to data types, we have a different kind of data types. Whether your data is, what are the data we have? We have a numerical and non-numerical, that is continuous data versus discrete data. Okay, continuous data and discrete data. Then you have a categorical data versus continuous and discrete data, numeric and non-numerical data. Numeric and non-numeric. Qualitative versus quantitative data. Qualitative data and quantitative. Big data versus non-big data. Intersectional versus time series data. Intersectional versus time series data. And we have live streaming versus batch data. So continuous versus discrete data, qualitative versus quantitative, balanced, imbalanced. The main concept is balanced data and imbalanced data sets. These are the something which comes under data understanding. So there are second category in data understanding. This is data types. So we will deep discuss in later point of time, and we have a data collection. In data collection, there are two types of data collections we consider. Primary data collection and secondary data collection. So data collections, we have a primary and secondary data collection. In primary data collection, we collect the data directly from the user. Directly from the user. Sorry, my bad. Pause this. So in secondary data sources, data already stored. Data has been already stored and already collected and stored in the proper format in any company, all sales record or company record, ERP, enterprises resource planning, or SRP tool, right? SAP tools. So these are the method we save the data. From that, we can collect the data. In the data sources, in the data collection, primary data sources is very expensive, time consuming, manual work, resources, a lot of resources is required. But good thing is we can collect the data whatever we want. Yes, we are asking directly to the customer. We are collecting the data directly to the from the user. But when come to secondary data sources collection, what are the disadvantage we have? Easily, the advantage is easily available. Not much time consuming. The main thing is the disadvantages. We cannot get whatever we want the data. Because the data stored as per the company norms. They're not collected for us. Then if the data is not sufficient, then we can choose for primary data collection. Got it? Yes, got it. So this is about the data collection. And when come to secondary data collections, yes, it is easy accessible, and we cannot, it is not expected what we have. Whatever data it has, based on that we can collect the data. Right? So that is about data understanding part. Data understanding policy. So now we come to the second stage, data preparation. So first thing is what we understand. We understand what is the business understanding. Then we come to the next step of data pre-process. What is the necessity of doing that? See, why do we do that? Because when you are data collections, the data is a raw format. The data will be in a raw format. Data in a raw format. So raw format in the sense, it will not cleaned. Okay, it should not be acceptable format in the machine learning algorithm. So we need to transform the data from raw data to useful format or some efficient format. This can be done by data cleaning or data transformation, data cleaning or data organizing or data transformation or data reduction. This also will be considered as a data pre-processing. We can. So data cleaning is nothing but the data have many irrelevant and some missing parts. For example, when you have we will talk more about in tomorrow's session, because tomorrow we will have sessions completely for data pre-processing. So let me tell you what are the data pre-processing, then we can detail we can see in the tomorrow. So first, let me, what are the data pre-processing major things in the machine learning? One is called typecasting method. Typecasting method helps to convert one data type into another data types. Next, we have handling duplicate values. Handling duplicate value in the sense, when you have a data set, in your data set, the repeated information will be there. For example, the number of customer rows, the same row will be available again also. For example, age, same kind of customers age, the pattern, the same pattern repeated. So that is called handling duplicate. And we have outlier treatment. So outlier treatment, all of us know, right? What is outlier treatment? Outlier treatment means the excess value. Outlier treatment, it is excess value. we have a different technique to identify box plot. We are using box plot to use differentiate or to make outlier treatment. And we have a discretization. The discretization method helps to convert numerical to non-numerical. Numerical to non-numerical. See, most of the data science, we expect the data to be a numerical, but in some cases, for example, the decision tree. In decision tree, we expected to be data to be a normal distribution. Sorry, we expected to the data should be, my bad. We expect our data should be non-numerical value. My bad. So non-numerical value. Fine. So non-numerical value. Let me open this. So what are the technique we discussed in data preprocessing? So typecasting and handling duplicate. Okay, discretization, handling duplicate, discretization, outlier treatment. Then what else we have? We discussed transformation, correct? Normalization, dummy variable creation, and we should have dummy variable creations or else standardization, missing values, duplicate value and missing values. So these are the data pre-processing we will be performed on any data set which we are going to work. Fine. And the third stage we come for model building. This is very, very important in model building. This is the backbone of the complete data set. Because we build the model, right? We build the model. The model in the sense nothing but constructing algorithm. We construct our own algorithm. For example, when come to machine learning, model building, we have two types. One is called supervised machine learning. Another is unsupervised machine learning. So supervised machine learning and unsupervised machine learning. When come to supervised machine learning, we have a data set. So when data set contain input and output, y is a variable, x1, x2, x3, and x5. So when your data is having input and output, that is called supervised machine learning. In your data, you have an input. Input means age, gender, salary, and some amount. So, but what about unsupervised machine learning? In unsupervised machine learning, you don't have output. All variable considered as an independent variable. We all know independent. Independent means input. Dependent means output. Why output is considered as a dependent variable? Because any output is dependent upon the input. Got it? Any output or any dependent variable, it can be rely on independent or input. So that is called output or dependent variable. So we have two types, supervised machine learning and unsupervised machine learning. What are the machine learning we will have? See, in unsupervised machine learning, we have a different kind of machine learning model we built. One is called clustering. In clustering, we have three types: agglomerative clustering, K means clustering, and we should have DB scan clustering. DB scan clustering. This is called clustering technique. And we have a PCA and SVD. PCA means principal component analysis. SVD, singular value decomposition. Singular value decomposition. And we have association rules. Association rules as well as we have a recommended engine system. A recommended engine system. Then we have a network analytics. Okay, so clustering topic, we have agglomerative, K-means, and DB scan. When come to PCA and SVD, we have principal component analysis, singular value decomposition. That's called SVD, singular value decomposition. It used to reduce the column. PCA is reducing the column. SVD is image, compress the image. Association rules. So association rules, we are talking about mainly used for retail store, retail business. So every retail business, there is a scope for using association rules, AR method. Okay, so where we are trying to identify the relationship between the products. Relationship between the products. When come to recommended engine, in recommended engine, in recommendation engine, for or online e-commerce, this physical store, this is for e-commerce website. All e-commerce business, we are recommending the product. We used to recommend the products to the customer. Network analytics. Network analytics will talk about the influence of social media. Okay, this is for unsupervised. When come to supervised machine learning, we have a KNN technique. KNN is classified technique and linear regression, logistic regression. Okay, linear regression, logistic regression, and SVM technique, multinomial, binomial distribution. Time series data forecasting, right? ANN, RNN, CNN, naive-based technique, decision tree, ensemble technique. So there are multiple important decision tree supervised machine learning we will have. So you can choose it accordingly. So whenever model is giving a best model, we can choose. So that is about super model building. We build the model and we talk about model evaluation. So model evaluation, evaluate model. See, it doesn't mean that whatever model you build always give a good accuracy. It is not in that way. Okay. So model building, in model building, you need to evaluate. We need to evaluate it. So always my model always will not give a correct predictions. We can't say that. So in order to select the model, we need to evaluate which model giving good accuracy. See, we can experiment a different model. There are some evaluation metrics we have here. See, before that, when your data, output data, let's assume there is the output data in model building. When your data is output is numerical value, when your data output is numerical value, you can continuous data. You can use continuous data. You can use regressive technique. When your data is discrete data, you can use classifier techniques. Classifier technique, especially for discrete data. When your data is continuous, then you are predicting the data. Got it? So discrete data. So when your data is regression model, you can use numerical. When your data is continuous, we can use regression technique. When your data is discrete data, we can use classifier technique. So this is you need to be understand in the model building. You need to concentrate or you need to give a important to the model building. This point you need to remember this. When model evaluation, when your data is continuous data, we have an error method, mean, absolute error. We can look at this model evaluation. So before that, we have a training and test data. We will see tomorrow how the train and testing. The remaining continuation, we will see tomorrow. Due to the time constraint, we will finish with the error method. For example, when your data, how do you evaluate that? In evaluate the data, for example, we have two types. One is called Y. Y means your actual data, actual output. Y hat. This is symbol of Y hat. That means predicted data. So actual data means Y. Predicted data is the predicted data. Okay. So actual minus prediction, that is called error. For example, when you are seeing this, when your data is 10,000, let's assume your output is 10,000. If your 11,000, if output is 11,000 expected, then what is the difference? It should be 1,000. So likewise, we need to calculate for all the values. For example, you can see the actual data herself. The forecast model or model 101. So error model is 1. The actual data is 200. Did you look at that? Look at this. Correct. So error with error term. Understood here? So actual data minus predicted data. When you add all, it will get. That's why we used to take square of them, means squared error. Because if we take absolute value, there is a chance for 0. So the best this value is root means squared error. We have mean percentage error. No, we don't look into that. The popular data, the popular accuracy is root mean squared error. Root means squared error. And mean percentage error mean absolute percentage error. There are other techniques or other error metric we have for numerical data. So now, when your data is non-numerical or classified table, what is you have? We have a confusion matrix. See, due to the time constraint, we will stop with this. Okay, so we have a scene once after the complete this, we can see tomorrow. So for confusion matrix, we are taking for non-numerical data, categorical data. So here we are not subtracting, here we are comparing actual data, for example, a pass or fail, let's assume. So let's assume the students' details, okay, pass or fail. If the person is actual data is pass, predicted data is fail. This is for pass, fail. And false, this is false, negative. False means negative, fail. Fail means negative. So fail means negative. This is true positive. This is false positive. False negative. This is true positive. This is true negative, fail, fail. Actual value is fail. Predicted value is also fail. So this is true negative. So crosstab, this is called as confusion matrix or crosstab method. So this we will use it for. This we will be using for non-numerical data, categorical data. When your output is categorical data, we use the confusion metric or error function. So there are good amount of information is pending. So we will continue with the same concept for tomorrow also. Then we will be proceeded about the data pre-processing. So data pre-processing, we are taking the data, we take the data, and we are looking for pre-processing. For data pre-processing. So apart from that, we are taking training and testing and validation data set. So what is training and testing validation data set is when you are having the data set needs to be split the data. We have to split the data. You need to split the data as a training, validation, and test data. So three type of tests we have defining that in training, validation, and test. Training split happen on randomly, the random split. So we are splitting the data randomly. In model evaluation, we will look at that. This is the basic of model evaluations. We take the data random data. So training separately and test separately. We split the data. That thing about it here. So this is about one of the criteria in model evaluation. There are multiple things we need to look into this, but due to the time constraint, and we are overfitting on networking. See what happened here. What happened in the training? In the training data set, we are constructing the algorithm. Okay, we construct the algorithms. So after we constructing algorithms, we are testing. That means we find the answer and we test the model. So we test the model. So based on the testing, based on the comparisons, we will come out with accuracy format. Accuracy means how much percentage will get accuracy for this. The percentage of accuracy. For example, out of 100, how many of you correct answer? Out of 100, how many correct answer? 95 correct or not? Or 100 correct or not? So you are doing some corrections or evaluation. So that's about today now. So don't worry, we will see tomorrow. We will talk about tomorrow in detailed manner. The remaining topics. So with this, we are stopping this. Thank you so much. Let me clear all.